Good afternoon, everyone. Today, our group is going to present a research about security in IoT. Our presentation has 4 parts in total. We will first introduce IoT and its corresponding security issues, and then discuss the cyber-physical systems in IoT through multiple layers. The third part will be the discussing about the related protocols and algorithms. Finally, we will conclude the research and express some future issues in our perspective. Internet of Things, also referred as Internet of Objects, which describes the network of billions of physical objects that are now connected to the Internet, collecting, transferring, and sharing data with other objects over the Internet. There are some security issues are raised. The Internet technologies and communication protocols may not guarantee the security of IoT devices. Threat actors can intercept them easily, since there are many ways devices can connect to each other. Cyber-physical system is a new paradigm that pursues the convergence of physical and cyberspace, which has become one of the core technologies for realizing Internet of Things in recent years. The CPS is divided into 3 layers, which are the perception layer, transmission layer, and application layer. Each layer is susceptible to be attacked. Many small devices on the perception layer do not have sufficient security protection, which leads that attackers may easily get access to sensitive data. And it is challenging to apply authentication support, such as implementing encryption on these devices, since the capabilities on many objects and entities in this layer are limited. In the transmission layer, devices are lack of the compatibility, which leads the communication among the devices are not protected. The existing network security architecture are not principally designed for the machine communications. So it is important to design a robust protocol to protect and encrypt the transmission between machines. In the application layer, the main security is the vulnerability resulting from the design of the applications. Adversaries may attack the system by launching malicious code and software in order to achieve personal information, such as user habits and health. A proper framework may be helpful to solve these problems. Now I will pass to Mingda for next section.
Thank you, Yuru. Next, I'll talk about network layer in the architecture, specifically the DTLS protocol. Network layer is where the communication of data occurs and is thereby one of the potential areas where security issues may arise. To make communication possible, it bears several protocols for communication parties to agree with. One of the prominent protocols that address security in this layer is Transport Layer Security, or TLS. However, TLS is typically used for TCP connections, which emphasizes on reliable data transfer. In IoT, there are circumstances when real-time feature is required. To solve this problem, Datagram Transport Layer Security, or DTLS, is introduced based on TLS. DTLS consists of 2 major components, Handshake Protocol and Record Protocol. Firstly, Handshake Protocol is used during the initial phase of communication. 2 parties negotiate which cipher suites to use, which are used to provide confidentiality, integrity, and authentication. Then, the shared secret used between the parties is DTLS is generated. When the handshake is successful, Record Protocol comes in and plays an instrumental role during data exchange between applications. The application data after Handshake Protocol passes through the phases of fragmentation, compression, and encryption in Record Protocol. It then gets sent to the destination and decrypted. A secure message exchange is then achieved. As for potential types of security attacks, the denial of service and replay attacks are the major concerns. The DOS attack can be resolved by implementing a stateless cookie during the handshake protocol, whereas the replay attack can be resolved by adding extra sequence number in the datagram. Besides, for the loss of messages, DTLS sets a timer during the handshake protocol and retransmission is triggered if the timer runs out. Therefore, the DTLS protocol offers an unreliable yet secure way of real-time communication for applications on IoT devices through appropriate selections of cipher suites during handshake protocol and performing encryption and decryption algorithms. Next, I will pass to Shanshan to talk about algorithms used in IoT. Shanshan, please.
Thank you, Minda. Next, I'll talk about the cryptography aspect regarding security in IoT. Processing complex cryptography algorithms tends to consume substantial computing resources and slow down the entire system, which can be very challenging for resource-constrained IoT-based devices. Therefore, there is a necessity for the cryptography algorithms used in IoT to be not only secure but also more importantly lightweight. According to the ECC algorithm, for one party to produce a public-private key pair, a random integer k is selected as the private key. The corresponding public key is computed by the scalar multiplication of k and a base point g, which leads to a resultant point q on the elliptic curve along the straight line. Given an elliptic curve, p and q, it is computationally intractable to solve k such that q equals k times p for a large value of k. Therefore, ECC is proven to be an effectively secure algorithm that can provide confidentiality for a secret key to be shared over insecure IoT networks between two parties. Moving on to the main reason that ECC is suitable to be used for IoT-based systems is that, compared to RSA, ECC provides an equivalent level of security with greatly shorter key sizes and reduced storage requirements, which means that it operates faster on resource-constrained IoT devices, consumes less computation energy, and produces less computing overhead. Another suitable cryptography option for IoT-based systems is the Symmetric Cryptography Scheme Advanced Encryption Standard due to its robust level of security per transmission bit, relatively smaller key sizes compared to RSA and ECC, and generally faster processing time. The ECC implementation should consider resource-constrained characteristics of IoT and the difficulties of dealing with the heterogeneity of IoT to be adaptive to different IoT devices. To sum up, we have covered CPS, DTLS, and cryptographic algorithms as state-of-the-art countermeasures that consolidate the security in IoT. Lastly, it is very important to note that the difficulty of security implementations and the security requirements differ from application to application, so the appropriate choice of security solutions highly depend on the specific IoT application itself. Thank you for watching.